Welcome to another edition of Math for No Risk. In this edition, we prove this interesting result. Suppose we have f, a real valued differentiable function, which satisfies the property that fx into f prime x is less than 0 for all real numbers. It is claimed that mod f is a decreasing function. Now note that fx into f prime x less than 0 means that if fx is greater than 0, then f prime x is less than 0. And if fx is less than 0, then f prime x is greater than. So f and f prime are of opposite signs. Now suppose we have 2 points x1 and x2 such that f of x1 is greater than 0 and f of x2 is less than 0. Now since f is a differentiable function, therefore it is continuous, and since f is continuous, by intermediate value theorem, which is abbreviated as IVT, there exists a point C lying between x1 and x2 such that f of c is equal to 0 there. But if fc is equal to 0, no matter what is the value of f prime c, then that is equal to 0. But we are given that fx into f prime x is less than 0. So there is no point c which is like this. That means there does not exist such points x1, x2 such that f of x1 is greater than 0 and f of x2 is less than 0. So the function f does not change sign on the real line. Okay, so the f maintains its sign, that is either fx is greater than 0 for all x or fx is less than 0 for all x. So either of these two things will happen. Now if fx is greater than 0, then f prime x is less than 0. We have already noted this. So if fx is greater than 0 for all x belonging to R, then f prime x is less than 0 for all x belonging to R. So the graph is of this kind. That means it's a decreasing function but always positive. If fx is less than 0, then f prime x is greater than 0 for all x belong to R. Then the graph is of this kind. But if we take a minus of this, then it will be a reflection of this and this will be of this kind. So if f is this, minus f is. So we see that so mod of fx, which is fx if fx is greater than 0, or minus fx if fx is less than 0, both of them are decreasing. So we have proved the claim that any differentiable function which satisfies this condition fx into f prime x is less than 0 for all x belonging to R must be a function for which mod f is a decreasing function. Thank you.